particular has to deal with kind of why the parabola gets the shape that it does. So, if you're looking at this journal, oops, wrong thing. There we go. So first off, we got our I can statement. So your I can statement for this journal is I can determine whether a parabola will have a maximum or minimum from its function. So essentially what we're trying to accomplish here is that, remember, on your EOC, you do have that calculator inactive part. And a lot of times during that part, they may throw in more vocabulary questions your way or more of form questions your way, stuff that you can easily do without a calculator. One of the questions that I've seen a lot on that EOC and the calculator inactive is, does this quadratic graph have a maximum or a minimum? And they don't actually give you the graph, they give you the equation. All right. And it's really, really easy to tell based off of one part of the function. And that's what we're going to learn about today. So these notes are going to be very, very quick, but it's just kind of telling you why the parabola either looks like a U or looks like an upside down U, why it looks like it has a maximum or why it looks like a minimum. There is a reason why that is. So the graphs of quadratic functions are a lot more complex than linear and exponential because they include that vertex or turning point. All right? Because if you think about it, with linear and exponential graphs, specifically in terms of their intervals of increase and decrease, linear graphs and exponential graphs only have one or the other. They're either increasing or they're decreasing. There's no in between. But quadratic graphs, as we've already learned yesterday, they do both. They increase at one point and then they decrease at another point. And their vertex is where they turn. So that's why they're a bit more complex than linear and exponential, because they have more to them. So that vertex and turning point, we already know, gives us either our maximum or our minimum y value. So it either gives us a maximum or a minimum. Now, we're going to do a little bit of discovery here. So what we're going to do with this next exercise is we're going to look at a very simple quadratic function, which is y equals negative x squared. That is a quadratic function. It contains that x squared. All right. And we're going to fill out this table to get us some points, because our end goal is to find the points that we can graph on our graph. Now, we're going to do this by hand because this is also something that they can throw at you, all right? But it's a very, very easy function to do by hand, all right? So these are our x values, and we're going to find our y values from our function negative x squared by plugging in our x value, and then that should then give us our point when we put the x and y together. So we're going to do this together. So we're going to plug in negative 3 in for our x. So we have negative times negative 3 squared. So the reason I put a second negative on the outside is because if you look at the x squared, it already has that negative in front. So if I just did negative 3 all squared, that would just be doing x squared, not negative x squared. So, by order of operations, what do I do first? Do I distribute this negative to the negative 3, or do I do the square first? You do the square first. All right. So, what is negative 3 squared? Not negative 9. Positive 9. Remember, negative 3 times negative 3 is a positive 9. All right? Now, we then do negative 9 times a negative or negative 1. What's negative? Not negative 9. Positive 9 times negative 1 is what? Negative 9. So this is negative 9. So our point would be negative 3, which is our x value, negative 9. And we're just going to continue to do that pattern. So the next one we have negative 2 in place of x. So we have negative 2 all squared. What's negative 2 squared? Positive 4 times negative 1. Negative 4. So this is equal to negative 4. So our point is negative 2, negative 4. Then we have negative 1. So we have negative 1 all squared is equal to. What's negative 1 squared? Not negative 1, but positive 1. Remember, square means you're multiplying it by itself. So you're doing negative 1 times negative 1. And a negative times a negative gives you a positive. So then what's positive 1 times a negative? Negative 1. So our y is negative 1. So the point is negative 1, negative 1. Then we have negative 0 all squared. What's 0 squared? 0. What's 0 times negative 1? 0. So our y value is still 0. Remember, there's no such thing as negative 0. It's just 0. So our point for this one is 0, 0. Then we have negative times 1 squared. Well, 1 squared is 1 times a negative gives you what? So what's 1 times negative 1? Positive 1. So this is negative 1. So our point is 1, negative 1. Then we have negative times 2 squared. What's 2 squared? 4 times a negative? Negative 4. So this would be 2, negative 4. And then our last point, we have negative 3 all squared. What's 3 squared? 9 times negative? Negative 9. So this would be 3, negative 9. So if I asked you to graph that by hand and it was a very simple function like that, that's all you would do. You just plug in your x value back into your function to get your y values. Now, before we actually get to the graphing part, let me ask you guys this. What do you notice about the y values? Kind of what's happening? What's something you notice about the y values specifically? They increase and then they decrease, right? So it looks like from here to here, they increase. And then from here to here, they decrease. What's something else that you notice? They're all negative in some way except for 0. What else? There's a pattern. What pattern are you noticing? So what looks like it's repeating itself? Are some of the numbers repeating? Yeah, some of the not the x values, some of the y values are repeating. So let me ask you this. Given that it goes from increasing to decreasing, where's the vertex? So where does it turn? At 0. So that's how, if I just gave you a table and told you to find the vertex, that's how you figure it out. You figure out where it's increasing, where it's decreasing, and at what point it turns. So this point right here, 0, 0, is our vertex. Now, do you think, let's do some predictions here. Do you think this vertex is going to be the maximum or the minimum? And why do you think that? So I'll give you a hint. Look at the y value specifically, and then look maximum. Why? The y values are negative. That's part of it, but why is it like absolutely a maximum? Elise.
Because the x values are like negative 3.
Not quite.
If the vertex is 0 and the y value is negative, so it's going to have to be maximum.
Right, because the vertex is your highest y essentially. So 0 is bigger than any negative number. So 0 is your highest y value, which means that's your maximum. So on top of that, your vertex will be a max. All right, that's how you know. If your y value, if your vertex y value is bigger than all the other y values, it's your max. If it's smaller than all your other y values, it's your min. All right. Now, let's actually just graph this very quickly. So I'm just going to go through and graph all the points that we just had. So we have 0, 0, negative 1, 1, or negative 1, negative 1, 1, negative 1, negative 2, negative 4, 2, negative 4, and then 3, negative 9, negative 3, negative 9. So your graph should look something like this. What did you notice about the graphing process while you were graphing it? They're like opposite each other, or like they're the same distance from each other. Why do you think that is? Just say it. I can decipher it.
Since y values are kind of all the same, x and y values.
Uh-huh.
And I don't think we can be 2 negative 3, so they have to be on 2 different sides.
Right. Okay, so that's kind of close to what I'm thinking about. What's one key feature that we learned about in the past 2 days that could guarantee that these 2 points are the same distance from each other? These 2 points are the same distance from each other. These 2 points are the same distance from each other. So it's something symmetry. Axis of symmetry. Where's my axis of symmetry at? It's at not just 0, but no. X equals 0. So remember, your axis of symmetry is a line that goes through your vertex. And if you look, this is 1 away from the axis of symmetry on both sides. This is 2 away from the axis of symmetry on both sides. This is 3 away from the axis of symmetry on both sides. They're the same distance, or they're symmetrical to each other. All right, that's why the axis of symmetry is called the axis of symmetry. So if you only have a couple of points, but you know the axis of symmetry, you can find the points on the other side by just figuring out the distance from the axis of symmetry. All right. Quadratic functions are symmetrical, meaning they are, if you folded it vertically over itself, you would get the same image. All right. Now, we already know that our vertex is a max. So the vertex is 0, 0, and it's a max. So given that, what's the range? So you always start with y with your range. So it's a y value. What would that y value be? 0, because that's the y value of the vertex. Less than or equal to. Why is it less than or equal to? The y's are decreasing from 0, or 0 is the biggest y value. So that means every other y value on our graph has to be less than 0. All right. So these are questions you need to ask yourself while you're doing stuff like this. So if they ask you to find the range, you need to ask yourself, okay, so we know it's a y value, so that's part of it. We know that it comes from the x value of the vertex. Not the x value, the y value of the vertex. That's the other part of it. All right. And then we just have to figure out the inequality. So you got to ask yourself, are my other y values besides this vertex lower than the vertex or higher than the vertex? If it's lower, it's less than or equal to. If it's higher, it's greater than or equal to. So guys, a lot of these key features, you can kind of logic your way through it. You just kind of have to think about that logical process. All right, it's not so much about formulas, it's more about can you think about it a little bit logically. All right. So, that being said, some parabolas open upwards, meaning that it looks like that U shape that we're used to, while others open downwards, meaning it looks like that upside down U shape. What do you think controls this behavior? So let's just make some predictions. Why do you think some of the parabolas open upwards, they look like a U, and others open downwards? So to help you out, look at the previous function. All right, y equals negative x squared. This function opened where? Upwards or downwards? It opened downwards. So, let's go with someone who hasn't talked yet today. Does anyone have any predictions why that is? Look at the function itself. What do you think, Foster? We were thinking it has something to do with a negative, all right? So we're going to make that prediction that it has something to do with the negative. We don't really know what per se, but we know it has something to do with a negative. So we're thinking it's going to have something to do with a negative. Let's actually find out, all right? So usually I would have you guys do this on your own, like to draw sketches of these graphs, but since we're kind of under a time constraint, we're just going to do it together as a class. All right. So for these next 4 examples, we're going to make sketches of the graphs of these 4 equations. All right. We're not going to like graph it perfectly. We're just going to make like a sketch so we know what the general shape looks like. All right. So what I'm going to do is that I'm going to graph these in Desmos. So my first one, I have y is equal to 2x squared. So if I'm looking at my graph, it looks like my vertex is at 0. There, it doesn't cross the x-axis anymore, and it's opening upwards. So I'm just going to draw a quick sketch of that. So vertex at 0, and it's opening upwards. So it looks something like this. And again, we're not going to be exact. We're just making a general picture. Then when y is equal to negative 3x, I'm going to graph that. Still has a vertex at 0, 0, but it's opening downward now. So we're going to draw a quick picture of that. All right. Then we have this long function, negative 2x squared minus 8x minus 4. So I have negative 2x squared minus 8x minus 4. So looks like we have a vertex at negative 2, 4. It crosses through the x-axis twice on the left side of the y-axis, and those points are not pretty, so we're not going to try to graph them. Y-intercept at 0, negative 4. So let's kind of make a quick sketch of that. So its vertex of this graph would be about right here. Its y-intercept about right here, and it crosses the x-axis about here and here. So our graph would look like this. So it opens downward, and that's what it looks like. Then lastly, our last one, we have positive 3x plus 6x squared minus 4. Or not 6x squared, 6x. All right. So looks like we have a vertex at -1, -7. It crosses the x-axis twice, one in the negatives, one in the positives. And we have a y-intercept at 0, -4. So let's make a quick sketch. Y-intercept's about right here. Vertex is here. Crosses about here and here. So it looks something like this. So they don't have to be perfect. We're just trying to make a general assumption of what the graph looks like. So now that we've drawn some general pictures, compare the graphs that are opening upwards to the graphs that are opening downwards. Which two of my graphs are opening upwards? A and D. So this one's up, this one's up. Which one's opening downwards?
B and C.
B and C. So this one's down and this one's down. Now look at their functions. So on your paper, because I know my screen's a bit small, but I'm trying to get so all 4 pictures are on there. Look at their functions. What do the opening downs have in common? What do the opening ups have in common? So take a minute, look at it. Look at their functions specifically. Look to see what they have in common. Why do you think one would open downwards while the other opens up? Okay, guys, too many heads are down. Open up. Wake up. Come on. Up, 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 up. All right, any predictions? Let's go with Elise.
For the top two,
Mm-hmm.
there's one is negative x squared and the other is positive x squared.
All right. That's an assumption. So what she said is that for these top two, one is negative while the other one's positive. Does that hold up for the other two? Look at what the values connected to the x squareds. Does the one opening downward, does that also have a negative x squared somewhere? Yeah. Negative connected to the x squared, positive connected to the x squared. That's actually what's going on. So what happens is that if your leading coefficient, or remember the leading coefficient just means the number connected to our highest exponent variable. So it's basically, in this case, the number connected to the x squared is positive. We're guessing it opens upward, or looks like that U. And if the leading coefficient, so again, the number connected to the x squared, is negative, we're thinking it's opening downwards. That's actually what makes our graph open either upwards or downwards. That A value, it all depends on that A value. All right. So if we look at this, we'll make official statements about that. So given our standard form of a quadratic, so that's y equals ax squared plus bx plus c, our parabola will always open upwards, or in other words, look like this U shape, if your a value is positive. So this a, the number a here, the value next to the x squared, if it's positive, it's going to open upwards. That also means that since it opened upwards, that it will have a minimum y value. And all that means is that your vertex is your min. So the vertex is your min for the graph. On the opposite side of that, the parabola will always open downwards, or in other words, look like that upside down U, if your a value is negative. So that number in front of the x squared is negative, which means that we would have a maximum y value. Or in other words, your vertex is your max. So that's really all this lesson is getting at. It's telling us why our parabola looks like the shape it does. why it's either looks like a U or why it looks like an upside down U. And the answer is that A value is either positive or negative, depending on the shape. All right. So if you saw a question like this on the EOC and they gave you an equation, they asked you to tell me whether it had a max or a min, you would first look to see if that first number connected to the x squared is positive or negative. If it's positive, it'll be a minimum. If it's negative, it'll have a maximum. And that's how you can tell without actually having to graph the function. All right. So let's look at some quick examples here. So example 1, they gave us a graph of a function and then they gave us 4 options. They want to know which of these could potentially be our function for that represents that graph. So let's kind of logic our way through this together. So first off, is this graph opening upwards or downwards? Downwards, meaning that it has a what? It has a maximum. So our vertex in this case is a max. So if it's a maximum, that means our A value is what? Negative. So we know that since we have a maximum, since we have a max, that means our A value is negative. So which 2 answer choices does that automatically eliminate? 2 and 4. Because if you look at all their A values, or the numbers connected to the x squareds, all right, the ones for 2 and 4, and remember there's an unspoken 1 here in front of the x squared, the ones in front of 2 and 4 are both positive numbers, while 1 and 3 are negative numbers. Now, we still have 2 answer choices we can pick from. So we now have to look at another key feature to see if we can reason our way through it. So let me guys ask you this. What form are all of these functions in? They're in standard form. So we've talked about this on Tuesday. What other key feature can I get from standard form just by looking at that function? Nope. What key feature? So what of the 5 or 6 key features that we learned over the past 2 days can I get from a standard form function without even having to graph it? There's only one other key feature that I can get from standard form. The y-intercept. Good. And what gives us the y-intercept? The c value. So we're going to look at the c values here. So the -5 and the +11. Now, our y-intercept is right here. Is this y-intercept positive or negative?
Positive.
It's positive. So based off of that fact, which one do you think our function is? It's 3. Because 3 is the only one with a positive c value, meaning that our y-intercept is positive for that graph. So our other reasoning is that our y-intercept is positive, so that means our c value is positive. All right. So again, a lot of these questions are just logic. It's can you identify what gives you these certain key features, and can you kind of logic your way through based on what you're looking at? Does that make sense? Yes, no, maybe so. All right. Because honestly, these questions are not very hard. You just kind of have to think about it in a more logical sense than in a more, 2 + 2 = 4 sense. You know what I mean? All right, last one. So this is very similar to what we talked about when we did our table at the beginning of this lesson. So it wants us to find the range. Now, before we find the range, we need to identify the vertex of this table without graphing it. So let me ask you guys this. Look at the y value specifically. All right. What's going on with the y values at first? They're increasing at first. Then what happens? They start decreasing. what y value does it turn at? At 11. So if they start increasing from 3 to 11, and then from 11 to negative 7, they decrease. Since 11 is where it turns, this entire point, 111, is my vertex. So, let me ask you guys this. Is this going to be a max or min? Max, why? Right, so on the left side of the 11, it's increasing, and on the right side, it's decreasing, so that creates a maximum. Or, if we're just looking at the y values, 11 is your what? It's the biggest number of your y values. That's another way you can tell it's a max. If it's a max, the y value of your vertex would be the biggest y value. If it's a minimum, the y value of your vertex would be the smallest y value. All right? So, given that range comes from the y value of your vertex, what's the only answer it could be? 4. Because it's the only one with an 11 in it. Plus, it makes sense because since 11 is our maximum, that means our y values have to be less than or equal to 11. All right, so listen up. You do have a new delta math for this. It's very short, pretty easy. It just goes over stuff that we've already talked about. All right, so you guys got about 20 minutes, so go ahead and get started on that. And then I'll post the exit ticket as well if you want to go ahead and knock it out. It's very, very quick as well. Also, if you finish your delta math, packet work for this lesson is pages 3 through 6 of your packet. Yes.